Okay, so as you can see, we're going to look at simple molecular substances, and two questions here which we can answer by drawing a very simple hydrogen molecule in the first instance. If we just draw a hydrogen bonded to another hydrogen atom here, and what we've got is a displayed formula, and what we'll do is we'll superimpose the pair of electrons on top of the displayed bond as well. And what we have here is obviously in the first instance a very simplistic covalent bond here. Okay, and that is obviously the bond which is holding each of the hydrogens to each other. And so that's what holds hydrogen 1 to hydrogen 2. But when we have a sample of hydrogen, we have one hydrogen molecule next door to another hydrogen molecule. So there are two hydrogen molecules, obviously that hydrogen molecule having its own covalent bond as well. And what we then have is a second bond that exists, even though it's not caused by any direct overlap of electrons, no giving or taking of electrons. There is a force which exists there, and this is an intermolecular force of attraction. Just go over question 2 here a bit, but this is the intermolecular force of attraction, and this is different to the covalent bond which holds a hydrogen atom to the hydrogen atom within the hydrogen molecule. And it's these two forces that we need to look at, or these two bonds that we need to look at. Covalent bond itself is strong. Okay, that's a very strong force. A covalent bond is a strong force. The intermolecular force of attraction between that is weak. And that's one of the reasons why hydrogen, for example, is a gas, because we don't need a lot of energy to break that. And so hydrogen molecule on the left here can be evaporated from the hydrogen molecule on the right because it breaks this bond in the middle, because that bond is very weak. So we can quite easily break that one. So there you see we have the two bonds there. Covalent holds hydrogen to hydrogen, but then the intermolecular force of attraction, which holds a H2 molecule next to another H2 molecule. And inferring that, we've also answered question 2 at the same time, really, because when a simple molecular substance melts, we were talking about boiling with hydrogen, but fundamentally the same type of issue is that, is it the bond between the atoms or the forces between the molecules that are broken? Well, the answer is it is the forces between the molecules that are broken, as we say. So if we take a simple molecular substance such as water, again, we have a water molecule next door to another water molecule. When we melt water, we are breaking the bond between the water molecules themselves. We are not breaking up a water molecule into its constituent hydrogen and oxygen atoms. Okay, so we do need to make that distinction. So when a simple molecular substance melts, we break the forces between the molecules. We're not breaking the bonds between the atoms.